So welcome to today's webinar with the ATG. I appreciate you tuning in today to learn about computers for civil engineering. I hope everybody is doing well and keeping busy. Today's webinar is a little different from the topics that I normally cover. Today we're going to be hardware focused, and I'm doing the whole thing in PowerPoint, so things I normally don't do. We're going to be comparing some computers and how they stack up against the requirements that today's civil engineering software really needs. You know, and when we're talking about computers, normally there's always the discussion of gaming computers and rendering computers, and a lot of it is focused on things that you wouldn't necessarily consider for civil engineering. So we're going to look at the things that Civil3D and Infraworks really need for what it needs to get, what Civil3D and Infraworks needs to really work properly. My name is Jason Artley. I am a senior technical specialist here at ATG. We're known for being a Autodesk Platinum partner, but we strive to be much more than just a reseller. In addition to Autodesk, we partner with Bluebeam, Esri, CTC Software, and some others. Our goal is to be your one-stop shop for software licensing, training, and support. And we love doing these webinars and creating content to help our customers become more efficient and proficient in the software that they use every day. In addition to software and training solutions, we also partner with hardware companies like BIMBOX and MSI, and we're going to talk about those companies later on today as well. If you have any questions, feel free to type in to the Q&A panel here in the Zoom interface, or you can always email me at jartley@atgusa.com. So today we're focusing on hardware, so let's get right into it. We're going to look at a few things. We're going to be looking at the computing requirements of Autodesk products like Civil3D and Infraworks. We're going to discuss the hardware terminology, all the different CPUs and GPUs, and sometimes it's confusing. We're going to focus on the four main categories of hardware. Then we're going to look at, the ROI, or the return on investment, between the different models and sort of the different approaches that we can look at when we're thinking about spending money on computers. We're also going to quantify the speed increase when we're looking at using hardware that's matched to the work that we're doing. So when we're talking about understanding computer requirements, usually the first step is to go to Google, right? If you type in Civil3D hardware requirements or Revit hardware requirements, sometimes you'll get the result from this Autodesk Knowledge Network, and it's been available for years, but never really for Civil3D. Back in Civil3D 2017, it was really hard to find what requirements it was actually looking for. So what a lot of folks did was that they went and looked at the Revit requirements, right? Revit is a more in-depth piece of software. So if it works for Revit, it should work for Civil3D, right? And it does work, and it's perfectly serviceable, but it's not exactly optimized. So now with this 2020 requirement, we see this on their website, and it says operating system, and it's got your browser, and it's got your processor, and it's just giving you a little bit of information. It tells you your memory or your RAM, talks about your resolution. It's really not giving you enough to properly spec a good computer. Now notice this is for Civil3D 2020, and it says Windows 7. Not even Microsoft supports Windows 7 anymore. So these minimums are seriously outdated. I know a lot of firms that haven't even used or haven't moved to Civil3D 2020 yet. They're still using 18 or 19, and it's still a fine piece of software. But when they start looking at upgrading, their IT manager or whomever's in charge of picking the specs for their computer might find this website that says the system requirements for Civil3D 2020, and they're going to think, oh, well, what they have is fine. This is just fine. And you can spec a computer based on this, and it will do okay. But we want to talk about doing more than okay, right? The computers that we're doing kind of rely on the work we're doing inside of the software, right? The Civil3D requirements haven't changed a whole lot, but our workflows have. We're asking more of the software, which in turn asks more of the hardware. Now, if we look at the computing requirements for Civil3D, it gives us the basic information, but as we continue down, it will say, well, there's additional requirements if you're doing large data sets, point clouds, or 3D modeling. Now, it's still giving you 16 RAM or more. It's not telling you that, hey, 13 is, or 32 would be better. It's not talking about some of the more nitty-gritty stuff that you need to know. And when you think about it, Civil 3D is intended to be used for modeling, 3D modeling, right? Because, let's go back. We're doing 3D modeling because we're employing that modeling mindset and applying those BIM strategies to Civil 3D projects. If you get a couple surfaces in your project, you're going to notice that your file size is going to grow quite a bit. So that large data set 3D modeling, this actually applies to almost every project that we're going to do. Now, there's really no such thing as too much power when it comes to Civil 3D. I mean, you don't do the bare minimum in your work every day. Why should we expect the bare minimum from our computers, right? So let's start talking about what all this stuff really means. We've got a lot of different requirements, and this is the one for Infraworks. Now notice, compared to the Civil 3D one, this goes into more detail. It's only going to let you use Microsoft Windows 10. It's recommending that you use a dual core or above CPU. It's telling you 16 gigs plus recommended. So even the way that Autodesk breaks down their software requirements is different between the two software. Now, you might not be using Infraworks yet. Hopefully you will. It's an amazing piece of software. But why this is listed differently than Civil 3D is that Civil 3D uses the computer in a different way. It can use the CPUs in a different way. Now, I'll throw out the big fat disclaimer if I haven't already. I'm not going to get into a super high level of detail when it comes to these scenarios, right? We're talking about gigs and gigahertz, and I'll mention some of that, but I'm not going to tell you the difference between 8 times anti-aliasing over something else, right? I'm intending this webinar to be, for us common folk, and I'm certainly a part of that. If I start talking about thread counts or anything like that, I'm probably talking about bed sheets. I'm not talking about CPU processing. So if you're expecting a more in-depth look at what all those things mean, stay tuned, because I will be providing a resource to read up on those things later on. So back to Infraworks. I mentioned Infraworks can use that CPU in a different way. They say that 8 gigabytes of RAM is minimum and 16 plus is recommended. Fine. It really should be about 32 gigabytes. If you were to spec a computer based on this alone, all of these should be the bare minimum that you're thinking about. If you spec a computer for Infraworks specifically based on these and you don't use the recommended values, you're not going to have a good time. Infraworks is intended for quick preliminary designs, right? It's all 3D based. It's going to, look at all sorts of different data sources, configure them and stylize them in different ways. And we're going to use that for preliminary design to lay out roads or sites. We're going to explore different configurations and drainage scenarios. We'll do some grading, some earthwork, and it's all meant so you can get it done quickly, so you can gain approval and move to your production once you may take it into Civil 3D. So when Infraworks doesn't work quickly, it can be a frustrating software to use. The whole experience changes dramatically when you're on a machine that can actually handle it. The level of detail and quality is enhanced. Your videos will produce quicker. Navigation is much quicker. It's just a better software when you throw more power at it. And the same thing works for Civil 3D. Now, there's a whole long list of what goes into a computer. There's motherboards and power supplies and CPUs and HDs and RAMs and GPUs, and we're going to look at the 4 main ones, right? We've got our CPU, or our processor. We've got our hard drive. We have our RAM, and we have our GPU, or our graphics processor, our video card. I'm going to explain the basics of these 4 parts, and then we'll get into how it's going to relate to our software. So our CPU, our processor, is what's allowing the work to be done. Lines to be drawn, calculations to be made, things like that. You'll often hear about CPUs with numbers associated to them. 3.2 gigahertz or 1.8 gigahertz or dual core, quad core, all this stuff. The gigahertz is the clock speed. The higher the gigahertz, the faster the work can be done. So it can draw those lines faster. It can make those calculations faster. When you take multiple cores, that allows you to do more work at the same time. For example, you probably have more than just Zoom running today. You probably got Outlook going on and maybe Civil3D in the background and whatever else. Multiple cores are helping your computer cope with having multiple applications open at once and to do multiple processes at once. So when we're looking at CPUs or processors, we want to look for a balance. I can get a higher clock speed with lower cores, or I can get more cores with lower clock speeds, right? So you might see something that's a 3.2 gigahertz dual core, and it might not be as fast as something that's a 3.0 gigahertz quad core, right? So we want to kind of balance and get the most gigahertz and cores we can get out of a possible processor. Now on this slide, I've got an Intel i9 9900K. That might not sound like a whole lot, but that is an absolute beast of a processor. It's what's in the machine that I'm using today for this demonstration and what I use for all of my other works. If you see this and it's in the cards, certainly put this on your shopping list. All right. Now, next up is the hard drive. Now, hard drives are fairly self-explanatory. That's what stores all the information on our computer. And these come in two varieties these days. We've got a traditional HDD, which is a hard disk drive, and we've got the newer solid state drives. The hard disk drive is, that's what's been out for years, and it's actually a mechanical device. It's physically reading and writing that media. So it's got moving parts, and it's, has stuff that it has to physically touch. The newer solid state drives, like this one, they have no moving parts. It's like a big flash drive. They're quieter, they're faster, and they're more reliable. Now, when we think about hard drive space, normally these are measured in capacity, right? I've got a 500 gigabyte hard drive or a 1 terabyte hard drive. And some of those, you would think that would make a sizable difference. And the capacity doesn't really have an impact on speed, unless you're running out of room. If you've got enough room on your hard drive, you'll be fine, but it's not going to make a difference in the speed. The spec we're looking for is the actual speed of the hard drive. Some hard drives can write faster and read faster than other hard drives, so they're not exactly created equal. So the faster it can read and write, the faster the computer is going to be. Windows is an amazing, thing that most of us rely on, but it's also a pretty complex program. And the faster your hard drive is, the faster Windows is going to work, the faster everything else is going to work. So if you were to switch from a hard disk drive here on the right to a solid state drive here on the left, you're going to instantly notice an increase on how fast that computer starts in the morning, how fast you save, how fast your drawings open, and that's sort of what we're focusing on today. Not just, the fancy parts of a computer to make it faster, but, what can we do with that extra time that we're going to gain by having a faster computer? All right. I'm going to circle, I see your question, Matthew. I'm going to circle back to that here in a minute. If you've got questions, type them into the Q&A and I'll either answer them where they fit in, or I'll circle back at the end and answer them. All right. So the third component here is our RAM, our random access memory. And I've got a picture shown here of some older stuff. The new stuff looks pretty fancy, but here we've got a few sticks of RAM, as they call it, inserted into the motherboard. And this is one of the most important components, because when you don't have enough, it's easily apparent. Sometimes you'll be doing something in CAD, or in my case, like Google Chrome tends to peg my RAM quite a bit. Then your computer will sit there and sit and think about what it's doing. It'll be, the fans will turn on, or it's just noticeably having a difficulty having difficulty processing the information. And that's actually your RAM trying to figure out what it's doing. And if you open up your task manager, just do Control-Alt-Delete, it will tell you how much of your RAM is being used and how much of your CPU is being used. It'll tell you how hard your computer is working. So if you're ever getting over like 40% utilization or so out of those, you probably don't have enough. So when we're talking about Civil 3D, it says, what did it say? 4 gigabytes is the minimum. And I find that to be absolutely untrue. For me, it's 32 gigabytes minimum. That's going to be enough for about 80% of your users, right? I run 64 gigabytes. The remaining 20%, you might want more than 32. If you're doing anything with point clouds or visualizations, especially InfraWorks, or point cloud surfaces in Civil 3D, 64 gigs is going to be great. Now, there's even a good case to be made for 128 gigabytes, and that's almost unheard of. If you're doing lots of drone stuff or lots of intense point clouds, or if you use some of the Adobe video software, 128 gigabytes. I mean, some of those pieces of software can access and use as much RAM as you can throw at it. So, but again, for most people, 32 gigs is enough. Now, we're not just looking at the capacity, like 8 gig or 16 gig or 32. We also want speed. So like our processor, RAM is doing the work. So a faster speed means more work it can get done. So this is usually labeled in megahertz. So you'll see like 2400 megahertz RAM or 3200 megabytes or megahertz RAM. And that's how many cycles it can do in a second. And that's actually like 2.4 billion for a 2400 megahertz, or 3.2 billion cycles a second for a 3200 megahertz. I said I wasn't going to get in that much detail, but I figure I'll throw a little bit out there. Now, some computers can be upgraded, and RAM isn't that expensive overall. When you're purchasing a new computer, make sure it's compatible with large amounts of RAM. So even if you can only afford something with 32 gigs right now, if it's expandable to 64 gig or more, you can always do those cheap upgrades later on, right? Maybe you're not using InfraWorks yet, and maybe you just want something for Civil 3D. Well, when you get to InfraWorks or when you get to point clouds, throw a couple new sticks of new RAM in there, double the capacity, and you're going to get a great improvement in performance. So I've saved the best part for last. This is our fourth main component, and that's our GPU, or our video card, or our video RAM. And Civil 3D, if we go back to the requirements, it's looking at one gigabyte minimum. And here I gotta say, 4 gigabytes makes a huge difference. As we've moved on to more 3D workflows, our graphics matter more than they ever have, right? It doesn't take much to have lines and text displayed. That's where 1 gigabyte is fine. But when we're doing animations in InfraWorks, or we're using Civil 3D's object viewer, or navigating through Navisworks, we need a proper GPU or video card to handle the task. Now, these are also measured in gigabytes, like we see here with our 4 gigabyte minimum, but there's also the refresh rate. The gigabyte portion makes sense, right? Higher the better. But let's talk about the refresh rate. When we're in Civil 3D, we're panning, we're zooming, we're changing styles, rebuilding corridors, performing surface analyses, things like that. That video card is doing all the work to reduce the lag between the command and what shows up on the screen. So the more power we can throw at it, the less time we're going to sit there waiting for it to load or refresh. Now, what's kind of unique here is that Autodesk normally doesn't recommend GeForce cards, right? I'll back up a little bit. We've got Intel, we've got AMD, we've got NVIDIA, and we've got other manufacturers that make different parts for our computers. And sometimes, you know, you'll see a preference one way or another for a certain model or manufacturer. And Autodesk typically doesn't like the GeForce cards. But these GeForce RTX cards are absolutely fantastic for civil engineering. My machine uses an RTX 2070, which this guy's shown right here. There's even a couple levels higher than this. So if you're doing point clouds or animations, you're really going to see a payoff when you add more power to your GPU or your video card. Especially if we were starting to talk about you doing some Esri stuff. Esri can absolutely use more GPU processing power. So if you're doing any sort of spatial analysis, if you're doing, you know, a lot of themes or things like that inside of Esri or even Infraworks, your GPU is going to pay off a lot right here. And what happens is, you know, we've looked at all these parts and we're looking at things that aren't necessarily cheap, right? And that's where it comes down to this. When we get to our return of investment, there's a brutal truth that we're going to have to sort of address, right? I've showed you things that would be almost unheard of 10, 15 years ago, right? When we're talking about speccing computers. Computers are expensive and they get outdated very quickly, right? So like most forms of technology, computers are constantly evolving. A top of the line computer 10 years ago has less power than the new smartphone, right? That same top of the line computer, it wasn't cheap either. We're spending all this money to get something that works great now, but how do we maximize that investment? So what we're going to do is, before we run the numbers, we're actually going to do some comparisons. But before we get to that part, I'm going to back up and get caught up on our question and answers. So I've got a question here about a Xenon versus an i7 and an i9 processor, and then GeForce versus Quadro video cards. And I'm going to link to a discussion on those very same questions at the end. That's where you know, that level of detail depends on what the software that you're using is actually looking at. There are some cases where a Quadro might be preferable over a GeForce, and it depends on your type of work. And there was another question here about our memory usage, about how I mentioned the RAM, right? So if you use your task manager and you do your Control-Alt-Delete, you're going to get this little task manager that pops up that tells you, hey, AutoCAD is using this much power and Windows is using this much power and whatever. And if you see your RAM getting pegged over 40% very often, that's where I think that you might want to upgrade. Now, I've had issues, not on this computer, but on my previous computer, where my RAM was getting pegged at 85, 90%, and it would sit there and hang, right? If I was trying to register a point cloud or something, it would take me a half hour or an hour just for it to go through. And that's where we're trying to look at some of those things. We don't want to max things out at 80 or 100% all the time. We want to leave room, because again, we don't just have one piece of software running, right? We've got multiple things going on. We've got Windows with its own hefty list of requirements, and then we've probably got, you know, all the other things going on in the background. So we want to leave room for everything to sort of work together. So that's where I mentioned, you know, if you're constantly seeing your RAM at about 40%, which means you're probably noticing a significant slowdown, or maybe your fans have kicked on or something like that, consider upgrading, or, you know, certainly put down on the list that, hey, you know, next time I get a computer, make sure I've got more RAM, because what I'm doing now can't handle it, which means as your workflows evolve into more of a 3D based or Infraworks or modeling based workflow, you're going to have additional slowdowns. All right. There's another good question about GeForce cards and AutoCAD not liking them, right? And if we go back several slides to where Autodesk had listed the requirements, it's not necessarily a concern about support from AutoCAD, but it kind of is too, right? It becomes a, again, we're an AutoCAD or Autodesk Platinum partner, and my goal is to be open and honest here with you. And I tend to call it as I see it. So if you were using a GeForce card, right? Let's say that GeForce is not recommended for AutoCAD, but you're using it anyway, and it works great 95% of the time, right? If you have a problem with that, it becomes an easy cop-out where they can say, oh, well, you're using an unsupported video card, so I guess that's the problem. See ya, right? It's the same thing as a car mechanic, right? You come in with a flat tire and like, oh, well, you had a CD in the radio, so that must be the problem. You know, it becomes one of those things. There are a lot of configurations and a lot of bits and pieces with computers that can be looked at or blamed when things aren't quite going right. And of course, with a software company, wouldn't they want to point to the hardware? Just saying. All right. So before we go on here, all right, there's a question about networking cards and which one is using an external document storage like ProjectWise. That's something I'm not going to cover. I've got nothing prepared for that because I'm not an expert in that, especially when we talk about ProjectWise. That's evil, right? We're an Autodesk Platinum partner. We don't want to talk about Bentley stuff. All right, let's get on to the ROI part, right? Now, I was talking about maximizing our investment. So before we do that, let's compare some computers, all right? Now, I use the Passmark test for comparing these machines. I compared 4 machines. 3 of them are mine. 1 of them is from a coworker, but we've got access to thousands of others for the sake of comparison. So if you go to passmark.com, you can download a piece of software called Performance Test. There's a free trial, get about a 30-day free trial on it, which will let you run the test. You know, it's pretty simple. It does take about 10 minutes to download, install, and run the test. And it's going to do all sorts of calculation and refreshing. It's going to put things up on your screen to test the various components, and then it will break it down for you. Now, before you click on passmark.com, I have a big fat warning for you. When you run this test, there's going to be a lot of sequences of flashing images and graphics and things flying by. So if you're sensitive to that, if you get motion sickness, if you have epilepsy or any of the other conditions that might be triggered by flashing sequences, absolutely do not watch the test. Hit start, go grab some coffee, go to lunch, whatever, come back later and get your results. But do not watch the whole thing going on. It's going to take you for a journey you might not like. All right. So I'm not going to demonstrate it for that very reason, and we're going to skip right to the results. So I'm going to compare 4 computers for you. And these are going to be based on numbers, right? Higher numbers are better. And we're starting with my old Dell. So a lot of you probably use Dell computers now. I've used them for a lot of my career. This is my personal computer. This is a Studio XPS 8100. It's about 9 or 10 years old, right? It's very similar to what was used in the industry, and it's very, these are still in place today. This was a $1,500 computer 10 years ago. It's not super high-end, but it's Dell. It's extremely high quality. It's not cheap, though, at $1,500 back then. In its prime, and it could do most games and computing functions. And even recently, I've used this computer for AutoCAD, and I've got Bluebeam Review on it. It still functions okay, but it's not fast at all. I wouldn't even bother with Civil3D. It would be pretty slow. So on that Passmark rating, it gets an overall score of 1,079. It's in the 13th percentile, which is pretty low. It's just not a great computer compared to what's out there today. And that's where we start talking about computers not lasting long. This was a pretty great computer 10 years ago, and now it's way down in the 13th percentile. I use that for basically internet browsing. I'll use it for some stuff with Fusion 360 because that's, you know, cloud-based. Any cloud-based stuff will still work on this just fine, but I wouldn't want to install Civil 3D or Infraworks on this computer at all. I don't even know if Infraworks would run on it, to tell you the truth. So the next computer is my personal machine that I use the most when I'm not at work. This is a Microsoft Surface Pro. It's less than a year old. Now, I really like this machine. It's small, it's light, super portable, works great for light processing. Bluebeam Review, Microsoft Office, Autodesk Sketchbook, Tinkercad, they work great on this. I haven't installed Civil 3D on it, but I know several people that do. This is a normal system these days that might be issued to a field engineer or a project manager. You know, someone who might not be doing a lot of surface modeling or corridor modeling or visualizations, but they're certainly opening up drawings. You know, they're doing PDF markups, they're doing things like that. And this is a great machine, but look at our pass mark score. It only gets a 1420 and it's in the 19th percentile. So it's not that much better than my 10-year-old it's still performing at that high level and providing all of that profit-making efficiency, right? Your workers are getting more done. You're able to do them and make those design decisions and design adjustments faster, which means we're being more efficient. All right. So as I mentioned, I'm going at a super high level, right? We're not getting down into some of the different settings in here. And I want to point to a resource to where you can find that information. There is a free white paper that you can download. This was done by Josh Radel in our Minneapolis team. He wrote this amazing white paper on BIMBOX computers, processors, other components. It gets down into another detail, a much higher level of detail than I would discuss today. I absolutely recommend downloading it and taking a look at it. He even breaks down the recommended configurations for VDC managers versus a BIM manager versus a civil engineer. Josh is an extremely talented person. I'm so glad that I get to work with him. He knows this stuff much more than I do. And not only that, he can harness the power of these computers to do amazing renderings and visualizations. Now, today's webinar was intended to discuss the hardware needed to make Autodesk software work perfectly for your workflows. I swear I wasn't teeing up a whole BIMBOX sales pitch the whole time. I'm speaking to you as a user myself. And this is the fastest computer I've ever used. If you want to have any of those numbers revised to show your actual company, like your billing rate versus how much you spend on your computers, our sales team can do that for you. And if you want to take a look at actual real world scenarios of certain processes in Civil3D or Infraworks on my computer, we can certainly do demonstrations and things like that as well. Now, I'm coming from a user background, right? I've been using Civil3D. I've been using Autodesk software for over 20 years. Not Civil3D because it hasn't been out that long, but I've been using software for a long time, and there's a huge difference in when you have the right tool for the job, and that's something that I tend to focus on. So I believe this is the best tool for the job. Not coming to you from a sales pitch, but if you actually want to see the difference it can make, we can demonstrate that for you. Now, with that, I want to thank you for your time today. Thank you for spending your lunch hour with me as we come on to our ATG webinar. Stay tuned for more, and we'll see you soon. Again, my name is Jason Artley with ATG, and have a good day, everybody.